We're going to use the setup that we developed in the previous video with a single button connected to the Raspberry Pi to develop a little program which is going to wait for a button press, and when the button is pressed, it's going to tweet to Twitter. To do this, we are going to use a Python program to monitor the status of the button in a bit of a different way than we did before. And we're going to use a really cool website called If This Then That, or ifttt.com, to handle all of the Twitter end of this project. More on that website later. First, let's talk about the button. So the button is connected identically to how it was in the previous video, where we made the turtle move around the screen and turn when the button was pressed. We have the power and the ground connected through a pull-down resistor to the button. See that video for more information on the setup. You can see the setup here in my webcam. I'm going to open a file, a Python file called twitterbutton.py. And as always, when we're using the GPIO pins, we need to import the GPIO package. I'll also import time, as usual, as well. We want to set up GPIO pin 26. Oh, first we need to set the Raspberry Pi to BCM board numbering, gpio.setMode, gpio.bcm. And then we need to set pin 26 as an input. In the previous video, we did a bit of a naive approach to a button press. We created an endless loop and then just checked the status of the GPIO pin every time through the loop. And then we did something if the button was pressed. Now we could do this in this case as well. Check the GPIO pin, say, every 5 seconds, and if it is pressed, then fire off the tweet. But this isn't the best way to do this. If we poll the status of the button once every 5 seconds, then what happens if we push the button and release it within that 5-second window? Now we could make that 5-second window even smaller, say half a second, but we still run the risk of missing the button press. If we made it so small, say 1/100th of a second, then we're pretty much guaranteed to capture the button press, but we're doing a lot of extra processing with the Raspberry Pi because we're processing hundreds of commands per second indefinitely while this program is running. So if all we want to do is wait for a button press and then do something when the button is pressed, there's a better way to do that, and that's with an event listener or an event detector. We can listen indefinitely for when the button is pressed and then do something if the button is pressed. So let's do this way. The first thing I need is a function that's going to be called when the button is pressed. So we haven't really talked about functions before, but you can read about that online in Python. In order to create a function, you use the def command for define. And I'm going to define a function called button pressed. And it takes one argument. I'll just call that argument. Doesn't matter what you call the argument. We aren't going to use it. And then you write a colon, and then on the next line, 3 or 4 spaces, whatever you're used to, indented. And then when the button is pressed, I'm just going to print the button was pressed to the screen. And there we have a function that will be called when the button is pressed. But we actually have to tell the Raspberry Pi now that we want this function to be called when the button is pressed. And to do that, we're going to add an event detect to the GPIO pin. So to do that, we'll type GPIO.add event detect. We want to listen to pin 26. And we want to listen for a GPIO rising. This means when we press the button, the pin goes from a 0 to a 1. The status of that pin goes from 0 to 1. So that is called a rising edge on a button. It rises from 0 to 1. If we connected the button in a slightly different way, or if we wanted to detect when the button was released, then we could listen for the GPIO falling event. And then we type callback equals button pressed. And that's all. This callback here is the function that's called when it detects a rising event on pin 26. So see here, button pressed is this function here that we wrote earlier. So let's take a look and see what happens. Oh, there's one thing I forgot. At the end of this Python script, I need to put a sleep command. Time.sleep. And this time I'm going to put a really big number here, 3,600 seconds or 1 hour. So this Python script will wait for up to an hour for this button to be pressed. If I didn't put this sleep command here, the script would just run and exit and would not continue to listen for the button being pressed. Now I'm going to close the script and run it by typing Python TwitterButton.py. Now the Raspberry Pi waits for me to press the button. So now I'll press the button. And you can see in the terminal, it says the button was pressed. I'll press it again. The button was pressed. So now it's intelligently waiting for the button to be pressed. Now we need to add Twitter support to this Python script. So I'm going to press Control-C to cancel the script. So now let's take a look at the website I mentioned earlier. If this, then that. So this is a really cool website that lets you connect different online and offline things to the internet. It does this through what they call recipes using different channels. We're going to use a bit of a custom recipe using a channel called Maker, which allows us to send commands from the Raspberry Pi to if this, then that, which will allow us to tweet. So once you've created an account, go up here to the search box and type in Maker. Instead of doing that, go to Channels at the top. And in the Search Channels box, type in Maker. Scroll down, and under the DIY Electronics, choose the maker channel. Choose Connect Maker, and it'll say Channel Connected. This special key here you'll need later. So go to or click How to Trigger Events and copy this line, this web URL here, to your clipboard for use later. Go back to the website and up here, click on your username and choose Create. Now we're going to create a recipe that uses the Maker channel to trigger a tweet to Twitter. So I'm going to click this to get started. And I need to choose a trigger channel. The trigger channel we're going to use is the Maker channel. And when the Maker channel receives a web request, we want an event to happen. So let's call our event button pressed. And I'm going to create the trigger. Now we need to tell it what the that is that we want it to do. And in this case, that is Twitter. We can have it do a bunch of different things with Twitter, but what we want it to do is post a tweet. So I'm going to click Post a Tweet. And we want our tweet to say, the Raspberry Pi button was pressed at, and then we'll click the ingredients button here and choose occurred at, which will add the date to our tweet. And then we'll click Create Action. So now we've set up our recipe. When the button pressed event occurs, then post a tweet to my Twitter account here. So I'm going to create recipe to finish this off. So now we'll go back to Python. We'll open up our Twitter button Python program. And we want to modify what the Raspberry Pi does when the button is pressed. So we'll go inside our button pressed function. And what we need to do here is access the URL that we copied earlier. So I'm going to make a variable called URL and set that equal to the variable or to the URL that we copied earlier. Recall that on the If This Then That website, we called the event button pressed with a capital B and a capital P. So we'll change this event here, placeholder for the event, to the name of our event, button pressed. Now we need to actually call this URL or request this URL so that If This Then That knows that our button was pressed. In order to call a URL from Python, we'll use the URL lib2 package. So we'll import URL lib, note 2 L's there, and then the number 2. Go back down here to our function. Then type URL lib2.url open, and then we want to pass it the variable URL. And that is it. If we close this file, and then run the Python script, it waits for a button press. Okay, and now I'm going to press the button. 3, 2, 1. Notice in the terminal, it says the button was pressed. If I go to Twitter and refresh my account page, I can see there's a new tweet. The Raspberry Pi button was pressed at February 1st at 9:26 p.m. So now the Raspberry Pi is successfully tweeting to my Twitter account. And you can imagine all sorts of possibilities that you can do with this. You could have a motion detector in your house connected to a Raspberry Pi that tweets to your account if it detects motion in your home. Just recently, I read online that someone wrote a program on their Raspberry Pi to test their internet speed. And if it was too slow, it would automatically tweet to their internet service provider complaining about the internet speed. So you can imagine all sorts of cool or annoying things you could do with a Raspberry Pi connected to social media. Thanks for watching.